Alright, welcome back. So after going through example 4-1, I hope you know more about how to apply the characteristic equation of the perfect gas. The next law that we're going to talk about is the 4.2 Joule's law. Okay, it states that the internal energy of the perfect gas is a function of the absolute temperature only. Okay, it means that the internal energy, which is one of the properties which we were talking about, okay, only depends on temperature, which means if temperature increases, internal energy will increase. Alright, so in mathematical terms, right, we say that internal energy is proportional to temperature. We can actually write this where K is an unknown factor lah. Okay, unknown constant, so it has a linear relationship. If you plot it in a graph form, right, T, U, it will be a straight line. Okay, so having said that, it was found that in fact the property of K for perfect gas is actually mCVT. Okay, where m is your mass, CV is your specific heat capacity under constant volume. Okay, this is yet another constant that is that different gases have different values of. There are a few main gas constants here. Okay, you have your R, you have your CV, which is shown over here, and finally you have your CP. This is actually specific heat capacity under constant pressure. Okay, these three will have a relationship which we will talk about later, but for now I just want you to concentrate on the fact that internal energy is purely dependent on temperature. Okay, if there is no change in temperature, that particular fluid will not have a change in its own internal energy. Alright, so this is what Joule's law is all about. And we can look at example 4-2 over here. The gas is heated from, okay, one more thing, this temperature must be in Kelvin. Okay, perfect gas chapter 4 is operating on Kelvin. You do not use degrees Celsius for its formulas. So 4-2, gas is heated from 25 to 95 degrees Celsius. CV is given. What is the change in internal energy per kilogram mass? Okay, so per kilogram mass means for 1 kilogram of gas. Okay, what is the change? The change in internal energy. Mass equals to 1 kilo. So this change is from the final state minus the initial state. Okay, so what is U2 over here? Your T2 is 95 degrees Celsius, which is 95 plus 273, which will give me 368 Kelvin, right? So U2 is mCVT2, 1 times 653 joules per kilogram Kelvin, okay, times 368. Let me check with the calculator. 95 plus 273, 368. Okay, so this is my U2. (240,304). U1 is the same mass times the same CV times the original temperature. So this is 25 degrees Celsius. Okay, expressed in Kelvin. (194,594) joules. Okay, so from first to second. So delta U is 240,304 minus 194,594. There's an increase 45710, or 45.71 kilojoules. Okay, so this is example 2, change in internal energy. Okay, so far we've been talking about how a perfect gas is supposed to behave, what it's dependent on, and the next section we will be talking more on the 5 main processes, okay, of the entire chapter. You have constant value process, constant temperature process, constant pressure process, and there are 2 very similar ones, which is the adiabatic and the polytropic process. Okay, no matter what process the gas is going through, right? Meaning it goes from an initial state to a final state. No matter what process, the characteristic equation can always be applied. Okay, as well as this relationship between the 2 states. No matter what process, these 2 can always be applied. So please make sure that you are using SI units for each of these properties. Okay, and you will not go wrong.